Today we're going to start chapter 2, which is reasoning and proof. So throughout this chapter you will be starting to look at how to reason your way through a statement and prove that the statement is either true or false. So today we're going to be discussing conditional statements. Alright, so there are some vocabulary words that go along with this. The first one is a conditional. A conditional is another name for an if-then statement. Alright, the next vocabulary word we have is hypothesis. So the hypothesis is the part of the sentence of the conditional following the if. Alright, the next is a conclusion. A conclusion is the part following the then. So it's the end of the conditional statement. And last but not least, we have the truth value. The truth value is when a conditional can have either a true or false value. Okay, so a conditional statement is either always true, or you can disprove it and say that it is a false, has a false truth value because you find a counterexample. Counterexample. All right. So, as I said, a conditional statement is an if-then statement. So, for example, we have, if you are not completely satisfied, then your money will be refunded. All right. That's an example of a conditional statement. So we have both parts. We have the hypothesis and the conclusion. So I'm going to underline the hypothesis in red of the statement. So that would be the if you are not completely satisfied. And then in blue I'm going to underline the conclusion part. So your money will be refunded. Alright. So those are the parts of a conditional statement. Alright, so we're going to try one. So you have to identify the hypothesis and the conclusion. We're going to use the same colors. So red for hypothesis, blue for conclusion. So if it is 12 o'clock noon, then the sun is shining. Alright, so the conclusion would be then the sun is shining. The hypothesis would be if it is 12 noon. Alright? Alright. If the car is full of gas would be the hypothesis. Then the engine will start is the conclusion. Okay? The last one is it is Monday if yesterday was Sunday. So in this case, our conclusion actually comes first. It is Monday. If yesterday was Sunday would be our hypothesis. Alright? Okay, so oftentimes what you can do is you can take a statement like an acute angle measures less than 90 degrees. Alright, fix my typos. Alright, an acute angle measures less than 90 degrees. So we can create an if-then statement out of this particular sentence. So for example, we could say, if an angle is acute, then it measures less than 90 degrees. Alright, so as you can see, we have our hypothesis and we have our conclusion. Okay? Alright, so as I was saying earlier, their conditional statements always have truth statements. Alright, and a truth statement can either prove your conditional true or false. So to show that a conditional is true, show that every time the hypothesis is true, the conclusion is true. So for example, in our previous if-then conditional statement, we had if an angle is acute, then it measures less than 90 degrees. Well, we know that no matter what, an angle that is less than 90 degrees will be classified as an acute angle. So the truth value of this statement would be true. Alright? So in order to show that a conditional is false, you just have to find at least one counterexample where the hypothesis is true, but the conclusion is false. So we'll look at some examples here. So we have this statement: if it is February, then there are only 28 days in the month. Now if you think about it, is it true or false? False. Because the counterexample is when you have a leap year, there are 29 days in February, not just 28. All right. All right. So we are going to look at we're going to look at one more statement. Figure out the truth value first. So we have if two lines intersect to form right angles, then they are perpendicular. All right. If you said that the truth statement is true, you are correct. Now, there is also something called a converse. A converse, and the definition is right here. A converse of a conditional switches the hypothesis and the conclusion. So in this case, we have the hypothesis is two lines intersect to form right angles, and the conclusion is they are perpendicular. Now, if I were to take these two statements and switch them and say if two lines are perpendicular, then they form right angles. Um, we are um, we are switching them and creating the converse of the original statement. Now in this particular example, we know that the truth value for both the conditional, the original statement, and the converse are both true. Now not every conditional and its converse have the same truth value. Sometimes they are different, okay? So we're going to take a look at that. So if you have a driver's license, then you are at least 16 years old. Okay? Think about it. If you said false, then you are correct. Okay? Now, if you are at least 16 years old, then you have a driver's license. That's also false. So in this case, there are some different ways we can look at that. So we have if the measure of an angle is between 0 and 90 degrees, then the angle is acute. Okay? So we look at that. We know that that's correct. If the angle is acute, then the measure of the angle is between 0 and 90 degrees. Both the conditional and its converse are true. All right, so we're going to look at them again some more. So we have if a point is is in the first quadrant, then its coordinates are positive. Okay, so if I were to write the converse, I would say if the coordinates are positive, then the point is in the first quadrant. Okay? So is the converse true or false? If you said false, or excuse me, if you said true, you are correct. Okay? All right. Now, there are symbolic ways of um, representing conditional statements and their converse. In this case, we use P for the hypothesis, um, and Q for the conditional, or for the conclusion. So in this, we have if an angle is a straight angle, then its measure is 180 degrees. Okay, so our hypothesis is coming first, and our conclusion is coming second. Now, in the converse, if the measure of an angle is 180 degrees, so that would be the original conclusion, then it is a straight line is the original hypothesis. All right, so we can actually identify conditional and converse statements using these symbolic forms. Okay, so just remember, hypothesis P, conclusion Q. Okay, Alright, so that concludes our lesson on everything you need to know about conditional statements, truth values, and their converses.